Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. 6 months after being fired, a former IT admin logs into the company's financial systems from his home at midnight. He still has full privileges. Nobody thought to revoke his access. With a few clicks, he deletes years of critical customer data. The damage was catastrophic. And this wasn't a sophisticated hack. It was a role that never got revoked. Role-based access control, or RBAC, would have prevented it instantly. I'm your host, and this is Hired in IT's IT Fundamentals Masterclass. In Part 5, we locked down logins with multi-factor authentication. Now in Part 6, we're diving into the access model that keeps your system safe from the inside out. By the time this video ends, you won't just know what RBAC is. You'll be able to define users, roles, and permissions and map them. Compare RBAC to ACL and ABAC, and implement a basic RBAC role in a cloud provider like Azure or AWS. Here are your 3 concrete takeaways. At its core, role-based access control is a simple indirection. We never assign permissions directly to a user. Instead, we create a role, like doctor, and attach permissions to that role. Then we assign users to the role. So Alice, the user, is assigned the doctor role. That role gives her the permission to read patient records. This indirect mapping gives us a single point of control for all access. Imagine you're managing a company with 500 employees. Each needs roughly 50 unique permissions across finance tools, HR systems, code repos. You're juggling 25,000 individual user permission relationships. A new hire takes 5 days to onboard because IT has to manually assign each permission. When someone leaves, you almost certainly miss revoking a few, leaving backdoors open. Audits become a nightmare of spreadsheets. That's the chaos RBAC eliminates. With RBAC, you define maybe 10 to 15 roles that map to job functions, not individuals. Onboarding becomes assign Alice the sales rep role, done in seconds. And because the role's permissions are pre-vetted for least privilege, a concept we hammered in Part 3, Alice gets exactly what she needs and nothing more. Every RBAC system boils down to 3 pieces, and missing any one of them breaks the model. The user can be a human or a service account. The role encapsulates a job function, and the permission is a granular action on a specific resource. Together, they form the RBAC triangle, and roles sit right in the middle as the translation layer between people and permissions. Consider a hospital. A doctor role gets read and update permissions on medical records. A nurse role can read vital signs but can't modify medication orders. And a receptionist role can only view appointment schedules, no medical data at all. Every user is assigned the least privilege needed for their job. If a nurse tries to access billing, RBAC blocks her cold. That's RBAC enforcing security and regulatory compliance automatically, without anyone having to hand-check every access request. Time to lock it in. Look at the scenario. A nurse suddenly sees billing data she shouldn't. Where did RBAC fail? RBAC's real power is in modeling business operations, not just files. Traditional access control lists, ACLs, Say, Alice can read this spreadsheet. That's fine for file shares. But RBAC says a loan officer can approve a mortgage application, which requires checking credit scores, updating underwriting systems, and notifying the customer. A whole workflow. That's the difference between a padlock and a process map. While RBAC rules based on role, attribute-based access control, ABAC, makes decisions on dynamic traits, time of day, device type, location. ABAC might allow a manager to view sensitive reports only from a corporate laptop between 8 a.m. and 6 p.m. That's powerful but also complex. RBAC is simpler and works perfectly when access depends on job function, not context. Many organizations lean heavily on RBAC. Others mix in ABAC for granularity. The rule of thumb: start with RBAC for role-driven needs. Add ABAC only when context truly matters, like remote work at 2 a.m. The NIST RBAC models, from basic to advanced role-based access control, isn't just an industry idea. It's backed by a formal model published by the National Institute of Standards and Technology, or NIST. For most IT professionals, there are 3 RBAC models you'll encounter most often. Core RBAC is the foundation. Users are assigned to roles, and roles are assigned permissions. That's the basic relationship we've been building throughout this lesson. Hierarchical RBAC adds inheritance. A senior role automatically receives the permissions of a more junior role and can also have additional privileges. That reduces duplication and makes large organizations much easier to manage. Constrained RBAC introduces rules that limit how roles can be used. The most common example is separation of duties, where one person is prevented from performing conflicting tasks such as both creating and approving the same financial transaction. NIST also describes additional capabilities for more advanced administrative scenarios, but these 3 models form the foundation you'll see in most real-world RBAC implementations. Understanding these models helps explain why RBAC can scale from a small business to a global enterprise while still remaining manageable. Hierarchical RBAC lets roles inherit permissions from parent roles, just like an organizational chart. A physician can read and write patient notes. The surgeon role inherits those permissions and adds the ability to schedule surgeries. The senior surgeon inherits everything from surgeon and gets an extra high-stakes permission: approve surgeries. This means you don't have to redefine common permissions for every role. Just extend the ones above. In healthcare, it maps perfectly to attending physician, resident, and intern relationships. Constrained RBAC, separation of duties. One of the most important ideas in RBAC is separation of duties, often called the 2-person rule. The concept is simple. No single individual should be able to complete an entire high-risk process alone. Imagine a purchasing system. One employee creates the purchase order. Another employee approves it. If the same person could perform both actions, fraud or accidental mistakes would be much harder to detect. Constrained RBAC prevents this by defining roles that cannot perform conflicting responsibilities. Many organizations implement this approach to support internal controls and regulatory requirements such as financial auditing, healthcare, and government compliance. The goal isn't to make work harder. It's to reduce risk by ensuring that important decisions require independent oversight. Time to test yourself. First, which CIA pillar falls when a sales rep can edit financials? Second, apply RBAC thinking to that infamous open S3 bucket from Part 2. A realistic healthcare example. Let's look at a realistic example. Imagine a hospital digitizing thousands of patient records. During the initial migration, someone suggests giving data entry staff permission to edit every medical record because it's easier. That sounds convenient, but it also creates unnecessary risk. A simple typing mistake could overwrite important medical information, and a malicious insider could intentionally modify patient records. A better RBAC design separates responsibilities. Data entry staff can create and import new records. Doctors and authorized clinicians can update medical information. Auditors can review changes without modifying anything. Every action is logged. This approach follows the principle of least privilege while reducing both accidental errors and unauthorized changes. Good RBAC isn't about making work difficult. It's about giving each person exactly the access they need, and nothing more. Implementing RBAC, a 5-step process. Now let's build an RBAC system the same way many organizations do. Step 1. Identify your resources. List the applications, databases, APIs, file shares, and cloud services you want to protect. Step 2. Identify the actions people perform. Can they read data, create records, modify information, delete resources, approve transactions? These become your permissions. Step 3. Design roles around job functions, not individuals. Instead of creating a role for Bob or Sarah, create roles like help desk technician, payroll administrator, or network engineer. Step 4. Assign users to the appropriate roles. Remember, one user may belong to multiple roles if their responsibilities span different departments. Finally, review access regularly. As employees change jobs, projects, or departments, their permissions should change as well. Many organizations perform periodic access reviews to ensure users still have only the permissions they need. RBAC isn't something you configure once and forget. It's an ongoing part of identity and access management. Here's the mistake that kills RBAC projects. You create a role named Bob because Bob has a weird one-off mix of permissions. Don't do it. Roles must mirror departments and functions, not people. In a typical org, you'll have finance roles like finance clerk and finance approver. Sales gets sales rep and sales manager. It has help desk and sysadmin. HR handles HR viewer and HR manager. A user can belong to multiple roles. A sales manager might also be in the HR role to view team attendance records. Keep roles business-facing, and you'll never end up with a Bob role. Let's see how RBAC works in Microsoft Azure. Azure uses Azure Role-Based Access Control, commonly called Azure RBAC, to determine what users, groups, service principals, and managed identities can do with Azure resources. Some of the most commonly used built-in roles include owner, contributor, and reader. An owner has full management access and can delegate permissions to other users. A contributor can create and manage Azure resources but cannot grant access to other identities. A reader can view resources but cannot make changes. If those built-in roles don't meet your needs, Azure also supports custom roles, allowing organizations to define exactly which management actions are permitted. This flexibility makes Azure RBAC one of the most important tools for implementing least privilege in cloud environments. Demo: Assigning an Azure role. Let's see how simple Azure RBAC is to use. Open the Azure portal and navigate to the subscription, resource group, or individual resource you want to secure. Next, open Access Control, IAM. Select Add Role Assignment. Choose the appropriate built-in role, for example, Reader. if someone only needs to view resources without making changes. Then select the user, group, or managed identity that should receive the role. After confirming the assignment, Azure applies the permissions defined by that role. Notice what we didn't do. We never individually granted hundreds of permissions. We simply assigned a predefined role. That's the real strength of RBAC. As organizations grow, administrators manage roles instead of managing thousands of individual permission assignments. On the AWS side, IAM roles are the RBAC engine. You create a role, attach one or more IAM policies, those are the permissions, and then assign that role to a user, an application, or even an EC2 instance. The role's trust policy decides who is allowed to assume it. For example, a web server role gets read-only access to an S3 bucket, while a DevOps role gets full deployment capabilities. By separating trust from permissions, AWS gives you the same RBAC flexibility. Define a role once, reuse it everywhere, and never hand out root credentials. Here's a real IAM policy that turns the principle of least privilege into executable code. The effect is allow, the action is S3, get object. Just reading an object, nothing else. There's no put object, no delete object, no list all my buckets. The resource line limits it to a single bucket, so even if someone mistakenly copies this policy, they can't access other S3 buckets. Attach this JSON to a role, assign that role to a user or application, and you've just built a secure, read-only boundary. That's RBAC in its purest form. No overprivilege, no surprises. Now let's see RBAC outside the cloud. In Kubernetes, it's how you control what a service account or user can do inside a cluster. Here's a role named pod reader that only allows getting and listing pods. No create, no delete. This is exactly the permission we said a monitoring tool service account should have back in the earlier checkpoint. Get and list verbs, nothing more. Below this, you'd create a role binding to attach this role to a specific service account in a namespace. And just like that, least privilege is enforced at the container orchestration level. In the earlier discussion, we learned zero trust means never trust. Always verify. That applies to roles too. Even if Alice has the doctor role, zero trust demands we keep asking, does Alice still need that role right now? That's where just-in-time access comes in. Tools like Azure Privileged Identity Management let a role be activated only for a configurable time, from 1 hour up to 24, then it disappears. It's like a key that materializes only when needed and then vanishes. So even if Alice's account gets compromised, the attacker can't use that admin role unless they request it and get approved, which adds a crucial time window for defense. Let's stack our defenses. Multi-factor authentication proves your identity. RBAC then limits your blast radius once you're inside. If a hacker steals your password but MFA blocks them, they never get a role. If they somehow bypass MFA, RBAC keeps them stuck inside a low-privilege role. That layered approach, MFA as the outer gate, RBAC as the inner vault, is why organizations that implement both see a dramatic reduction in account takeover risk. It's not either-or. It's the 1-2 punch that makes a security architect's life easier. Let's connect the dots across the series. You learn the principle of least privilege in Part 3. Give users the bare minimum access they need. How does RBAC actually enforce that? Think about it. What? Got it? The answer. RBAC bakes least privilege right into the role definition. When you assign reader in Azure, that role has been predefined to contain only read actions. No write, no delete. So even if you wanted to mess up, the role won't let you. That's a direct technical enforcement, not just a policy. There's a reason RBAC is everywhere. First, security. Every user only sees what their role needs, so if a sales account gets phished, the attacker can't reach HR records or billing systems. Second, compliance. Regulations like HIPAA and PCI DSS, the payment card data security standard, demand you prove who has access to what. With RBAC, an auditor just looks at the role definitions instead of digging through individual permissions. Third, pure speed. New hire shows up, IT assigns the marketing staff role, and they're working in minutes instead of waiting days for someone to manually approve 20 different permissions. But RBAC isn't a silver bullet. The most common trap: role explosion. You start with 5 clean roles, but then Bob needs a weird mix, so you create a Bob role, and suddenly you have 200 roles, which is just as messy as managing individual permissions. The other gotcha: stale roles. An employee switches from marketing to engineering but keeps their old marketing role, granting access they shouldn't have. And remember, RBAC is static. It doesn't consider time of day or device health. If you need that dynamic context, that's when you reach for attribute-based access control, or ABAC. Schedule regular access reviews to clean up those dusty roles before they become a liability. All this RBAC knowledge translates directly to a high-paying role you might not even know about: Identity and Access Management Analyst. While SOC analysts start around $55,000, entry-level IAM analysts earn $75,000 to $90,000, and remote IAM specialists can reach up to $150,000. The field is less crowded, tightly coupled with cloud growth, and right now CyberSeek shows over 514,000 cybersecurity openings in the US, many of them in identity and access management. If you can design a role structure and write an IAM policy, you're already speaking the language of a 6-figure job. Here's your 90-day plan. First, what you just learned is the foundation: RBAC, ABAC, the NIST levels. That's your mental model. Second, don't just watch. Sign into the free tiers of Azure and AWS. Create custom roles, attach policies, break things. Third, pick a certification: SC 300 for the Microsoft Identity Path, or the AWS Security Specialty to cover IAM in depth. And the game changer: 30 minutes a day of hands-on labs. In 3 months, you'll have a portfolio of IAM configurations you can actually show in an interview, and that gives you a significant edge over candidates who only have theory. Let's lock in the 3 things that matter. 1. RBAC isn't about users, it's about roles. Map users to roles, roles to permissions, and use scale access from 10 to 10,000 people without chaos. 2. There are 3 levels: core for basic assignment, hierarchical for inheritance, constrained for separation of duties, and you must know which one fits your problem. 3. This isn't just theory. The moment you create a role in Azure or AWS, you're practicing a skill that directly maps to identity analyst jobs starting at $75,000 and climbing fast. That's the path from help desk to security engineer. So you've built the walls with RBAC and the gates with MFA. But what protects the data when it's just sitting on a disk or flying across the internet? That's where encryption steps in. In the next video, we're breaking down AES, RSA, and TLS without the math panic. And you'll understand exactly how RBAC depends on encryption to keep your data safe at rest and in transit. Watch it to complete your security stack. Before you go, lock in the biggest takeaway. Across AWS IAM, Kubernetes RBAC, and just-in-time access tools, The one constant is least privilege. Everyone, user, service account, EC2 instance, gets only the bare minimum permissions. That's RBAC's superpower, and it's what gets you from theory to a real IAM analyst role. Now go apply it.